Now let's understand the Kepler's law. So Kepler had given some laws regarding to the प्लानिटरी मोशन। तो जब हम लोग न्यूटन के ग्रेविटेशनल लॉ को पढ़ते हैं या न्यूटन के द्वारा दिए गए लॉज को समझते हैं, तब हम लोगों को कैपिलर के लॉ को भी समझने की जरूरत होती है, बिकॉज इट गिव्स अस एन अंडरस्टैंडिंग that how our solar system used to work, how the planets used to go around the sun, and how it used to have different kinds of calculation regarding to this one. So about Kepler, you will study in your class 11's physics, but here we will just get a little bit of information about what kind of information he had given, what laws he had provided us. So we can say it as Kepler's law of gravitation, or we can say as Kepler's law of planetary motion. तो बेसिकली अगर हम लोग देखें तो इन लॉज को तीन अलग अलग पार्ट्स में डिवाइड किया जा सकता है। द लॉ ऑफ एलिप्सिस, the law of equal area and the law of harmonics. तो लेट्स इनको देखते हैं कि ये इनमें क्या ऐसी बातें हैं जिनको कि ये ग्रेविटेशनल के साथ कनेक्ट करती हैं। See students, gravitation is a very important thing for the planetary motion also, because as we had discussed in the previous part of this lecture that when we see for the gravitational force of the sun, that is only the reason why all the planets are going around the sun, and our earth is also one of the part of that one. So what kind of motion it goes, or in what kind of path it has, that explains by the Kepler's law. So let's understand about it. द फर्स्ट लॉ ऑफ कैपिलर, और कैपिलर के पहले लॉ के रूप में अगर हम लोग देखते हैं तो हम लोग समझते हैं यहाँ पर क्या कहा जाता है। सो द लॉ ऑफ एलिप्सिस, सो दैट इज द लॉ फॉर द ऑर्बिट ऑफ द प्लैनेट्स। तो हम लोगों ने ये समझा है कि हम लोगों के सन का जो प्रेजेंस है वो हम लोगों के सोलर सिस्टम में सेंटर में है, और जितने भी प्लैनेट्स हैं वो उसके चारों तरफ घूमते हैं। तो जब ये प्लैनेट्स सन के चारों तरफ जाते हैं तो उनका एक सर्टेन पाथ है जिसको कि हम लोग ऑर्बिट कहते हैं। तो ये किस तरह का ऑर्बिट है, ये कैपिलर ने हम लोगों को समझाया है। तो फर्स्ट लॉ जिसको कहा जाता है द लॉ ऑफ एलिप्सिस, ये समझाता है कि हम लोगों का जो 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 प्लैनेट्स का पाथ है दैट इज इन अ फॉर्म ऑफ इलेप्टिकल ऑर्बिट। ये एक इलेप्टिकल ऑर्बिट में, इलेप्टिकल ऑर्बिट को एक सिंपल तरीके से समझने के लिए हम लोग इस तरह से देख सकते हैं। Suppose that there is a big circle, suppose there is a big circle, and there is another circle which is little smaller than to this bigger one. Okay, so it is a little smaller than to the bigger one. Now you just imagine it in this way that the sun is present at the center of this big circle. Okay, and our earth, or any of the planet is going around this sun on an orbit which is just the path which is touching to the circumference of these two circles. तो इन दोनों circles के जो circumference है, इसका जो ये path formation होता है, ये जो curved path formation होता है, this is the path for the orbit of any planet around the sun. So this is known as an elliptical orbit. So you need to remember this thing. This is called to be an elliptical orbit. And as I said that we will discuss this thing in detail when we will go for the class 11's physics. Okay. Now let's move to the second law, that is the law of equal area. So what does this law actually says over? So in a simple way, you can say this thing that when the planet used to go around the sun, then it sweeps out equal area in an equal amount of time. So what is that? So over here in this figure, you can see this thing that at different position, the planet has to cover different distances. Okay. So even though the distances are different, but it takes the equal time period to cover all the places. So either this one, or this one, if you will go for the calculation of the area, you will find that the area is same from this point to this point, and this area is same for each and every condition. But the time taken to cover each of these areas will be the same over here, even though it seems little bit of different in the orbital radius. Okay, तो ये जो ऑर्बिट है, जैसे कि फॉर एग्जांपल ये वाली जो पाथ है, ये सबसे लंबे पाथ हम लोगों को दिख रही है, या फिर इधर सबसे लंबी पाथ हम लोगों को दिख रही है, और इधर सबसे छोटी सी पाथ दिख रही है हम लोगों को। तो एरिया वाइज अगर देखते हैं तो दोनों में एरिया सेम होती है, लेकिन अगर ऑर्बिटल आर्क को देखते हैं तो उसमें काफी चेंजेस आती हैं। तो यहाँ पर जो ऑर्बिटल आर्क है ये काफी बड़ा है, और यहाँ पर ऑर्बिटल आर्क काफी छोटा है, बट वी विल ऑब्जर्व दिस थिंग that the time taken by the planet to go around for this arc will be equals to the time taken by the planet to move on this particular arc. So this is the concept which we have to understand over here, and on the basis of this thing only we will see one very basic understanding of the motion of the planet. तो अगर हम लोग planet का motion के बारे में देखते हैं तो एक बहुत important सी चीज हम लोगों को समझने की जरूरत है. When the planet is reaching nearby to the sun, its speed increases. Okay, and this is the reason only why it covers a longer path then compared to this shorter path. So जब ये यहाँ पर होती है, जब वो planet जो है वो सूरज से सबसे दूर होती है, at that time its speed is minimum. Whereas when the planet is nearby to the sun, at that time its speed is maximum. So this is the basic reason why we can observe this thing, that it sweeps out the equal area in equal time period, even though the area which we are talking about, it has different arcs. So you can see this arc is the longest one and this one is the shorter one. So both the arc will be covered in the same time period. So this used to be the second law. Okay. Now, let's move to the next one. This is the Kepler's law of third. So third law को हम लोग harmonics भी कहते हैं, या फिर law of harmonics भी कहा जाता है, where we used to observe that there is a establishment of relation between the time period of the planet to go around the sun with respect to the distance covered by the planet. तो जब भी कोई भी तरह के planet या कोई भी planet जब सूरज के चारों तरफ ट्रैवल करती है, तो वो एक पर्टिकुलर डिस्टेंस को कवर करती है एक पर्टिकुलर टाइम पीरियड के साथ. तो हम लोगों ने ये ऑब्जर्व किया है, या फिर ये कैलकुलेशन में ऑब्जर्व हुआ है कि देयर इज अ पर्टिकुलर रिलेशन बिटवीन द टाइम पीरियड विथ रेस्पेक्ट टू द डिस्टेंस कवर्ड बाय द प्लैनेट. So what is that? So we can say this thing, that the t square, the time periods square, is directly proportional to the cube of the mean distance covered by the planet. तो जब हम लोग टाइम पीरियड के बारे में बात करते हैं, तो जितनी टाइम पीरियड लगती है किसी भी प्लैनेट को एक पर्टिकुलर डिस्टेंस को कवर करने के लिए, उसको अगर हम लोग रिलेट करते हैं उस डिस्टेंस के साथ, तो हम लोग ये ऑब्जर्व करते हैं कि टाइम पीरियड का स्क्वायर जो होता है वो डायरेक्टली प्रोपोर्शनल होता है डिस्टेंस के क्यूब से. तो डिस्टेंस का जो क्यूब होता है उसके डायरेक्टली प्रोपोर्शनल होता है. सो यू कैन मेंशन दिस थिंग एज लाइक दिस आल्सो, that r cube is directly proportional to t square. Okay, so this is also a very important thing which we need to remember. Now, as we had studied earlier also, that directly proportional sign doesn't help us to solve any equation in a proper way. So what we used to go for, or what we can say over here, that this directly proportional can be removed with an equals to sign with a k constant. ठीक है, तो ये अगर हम लोग लेके आते हैं प्रोपोर्शनल कांस्टेंट अगर लेके आते हैं, तो इस इक्वेशन को सेटिस्फाई करने के लिए आर क्यूब इज इक्वल्स टू के टी स्क्वायर हम लोग कर सकते हैं. तो ये जो फिनोमिना हम लोग यहाँ पे ला रहे हैं, वेयर वी आर गेटिंग फॉर दिस थिंग दैट आर क्यूब इज इक्वल्स टू के टी स्क्वायर, with this one we are going to establish a relation with the Newton's सेकेंड लॉ. द ग्रेविटेशन का जो सेकेंड लॉ न्यूटन ने दिया था, वो कैपिलर के इसी लॉ से डिराइव करके लेते हुए आते हैं. So over here, if I will go for this one, then it will be r cube by t square is equals to k constant. So you can say this thing, that this particular ratio or this particular component is a constant value. So you please keep this thing in mind, because we are going to use this equation further when we will understand the relation between the Kepler's law with the Newton's third law. So I hope that you all had understood till here, and these are the things which you have to just go for a while, and you just need to understand the basic concept, because as I said earlier, that you will study about these things in much detail when you will study again these things in class 11's physics. Okay. Now, as I was saying earlier that we have to establish the relation between the Kepler's law with the universal law of gravitation that the Newton had provided us. Okay. So what is that? Now, see students, while we had started this lecture, we had understood this thing that under Newton's law of gravitation, he had proposed this thing that the force of gravitation is directly proportional to the product of masses of the two bodies. Then he has said that the force of gravitation is inversely proportional to the square of the distance between the center of the two bodies. Over here, this second law, he had actually derived it from the Kepler's third law. So Kepler had proposed his laws before than to Newton's law. So Newton had used Kepler's law to derive his own universal law of gravitation. So there was no any problem with that one, because at that period of time, scientists used to ask, or they used to communicate with each other to give a challenge to solve the relation or to establish a relation. So in that one, a healthy relation was there between Kepler and Newton, and so Newton had used his laws, and with that one, today we know about the Newton's law of universal gravitation. So how we can go for this one? So to make it understand for this thing, we have to go for the basic understanding of the gravitation, what we had already done earlier. While we were discussing earlier, we had understood this thing that the gravitational force is nothing but it is the सेंटीपिटल फोर्स. ओके, सो जैसा कि हम पहले भी बताया हुआ है कि एक सेंटीपिटल फोर्स है, ग्रेविटेशनल फोर्स एक तरह का सेंटीपिटल फोर्स है. सो वी आर गोइंग टू कैलकुलेट विद द सेंटीपिटल फोर्स ओनली. सो फोर्स ऑफ सेंटीपिटल और सेंटीपिटल फोर्स एज अ ग्रेविटेशनल फोर्स. सो इफ यू विल गो फॉर द सॉल्यूशन फॉर दिस वन, you will go for it as mv square by r. So this is the basic rule to calculate the centripetal force. So as we know this thing, centripetal force creates a circular motion. It causes a circular motion. Hence, we have this R as the radius. M is the mass for the body which it is going around it, and V is the velocity by which it is moving. Now, if I will split this equation and go for it as M into V square by R, so I don't think that there would be any kind of problem. Now you assume it like this, that this m is a proportional constant. Okay, so we will assume that let the m is the proportional constant. Okay, so why I'm taking it as a proportional constant? Because when we are talking about universal bodies or the bodies which is in the space, so they have a huge mass. So I'm just assuming that for any particular body. So for any particular body, I'm taking it as a constant condition. So under the constant condition, what will happen over here? So we can say that the force of centripetal force is directly proportional to V square by R. So now with this one, you keep it as equation 1. Now let's move to the velocity. Now let's go for the velocity. The velocity. Now, as we are talking about the centripetal force, and we had already understood this thing that the centripetal force creates a circular motion. Centripetal force जो है एक circular motion create करता है. तो circular motion के लिए अगर हमको velocity का calculation करना हो, तो हम लोग कैसे calculate कर सकते हैं? So that we had already understood in the chapter motion. Okay, so V over there in a circular condition, 2 pi r by t. ठीक है, तो 2 pi r क्या दिखा रहा है? वो हमको डिस्प्लेसमेंट दिखा रहा है, और t हमको क्या दिखा रहा है? टाइम पीरियड दिखा रहा है. So over here also we will go for v is equals to 2 pi as a separate component into r by t. Now over here again I will assume this thing that this 2 pi is variable constant. Okay, so we will take that, let 2 pi 2 pi is the variable constant over there. So when it is like that, so you can say it as v is directly proportional to r by t. So this is the thing which you are getting by this. Now we are going to derive for this particular equation. So when we are having v is directly proportional to r by t, if I will go for squaring both sides, so squaring both sides. So what we will go for this one, so it would be V square is directly proportional to R by T's whole square. So you are going to get it as V square is directly proportional to R square by T square. Now for this thing, we can also write it as V square is directly proportional to R cube by T square into 1 by R. I hope that you all had understood this thing, that how this R cube is related to this R. So if R and R will be cancelled, it is actually R squared by T square. Now, if you remember, just we had done the Kepler's third law where we had understood this thing, that this has been taken as constant. So if this is constant, so we can say this thing that V square is equals to, V square is equals to 1 by R. So take it as equation 2. Now place this value of equation 2 in the equation 1. So when you will place it, so you will get the force of centripetal or centripetal force is directly proportional. The centripetal force is directly proportional to 1 upon R by R. So when you will solve for this one, then the force of centripetal is directly proportional to 1 by R square. So this relation gives us the second law of Newton. So the centripetal force, earlier only we had discussed this thing, that this centripetal force is actually the gravitational force. ये gravitational force ही है, क्योंकि gravitational force centripetal force के तरह act करती है. ये चीज हम पहले ही discuss कर चुके हैं और यहाँ पर भी हम लोगों ने उसी को derive किया है. So you can understand this thing, that this gravitational force is inversely proportional to the square of the distance between two bodies. So this is the condition which we need to remember when we discuss about the Newton's law of universal gravity. Okay. Now let's move to the next part of this understanding. So here we are coming to the end of this chapter. So we are going to discuss about the motion, mass and weight. तो मास और वेट क्या चीजें हैं? ये दोनों ही एक दूसरे से रिलेट करती हैं, दोनों ही एक दूसरे को रिलेट करती हैं, एंड बोथ आर वेरी वेरी इंपॉर्टेंट कंपोनेंट फॉर अस. Now, when we go for the mass, how we can define this mass? So in a simple way, you can say that mass is the total number of particles present in a particular body or in an object. तो तुम लोगों ने ये पढ़ा हुआ है कि जितने भी तरह के मैटर होते हैं वो सभी चीजें बनी हुई होती हैं छोटे छोटे पार्टिकल्स से. सो ओवर हियर आल्सो when we say for the matter, the total number of particles which is present in that matter gives its the mass. तो कोई भी मैटर अगर है तो ऑब्वियस सी बात है कि उसमें पार्टिकल्स होंगे ही होंगे, और जितने पार्टिकल्स होंगे उसके बेसिस पर उसकी एक मास कैलकुलेट की जा सकती है. Whereas weight जो होती है, weight is actually a condition which used to cause due to the gravitational pull. So it is just due to the gravitational pull which is created on the earth. तो जब भी किसी भी तरह के बॉडी जिसमें मास है, या कोई भी बॉडी जिसके पास एक सर्टेन मास होती है, उसके पास एक सर्टेन वेट भी होता है. क्यों होता है? बिकॉज दैट बॉडी बिन अट्रैक्टेड टुवर्ड्स द अर्थ्स ग्रेविटी. And due to this only, we consider that mass as a scalar quantity, whereas weight as a vector quantity. So mass is a scalar quantity because it has only magnitude. Magnitude means total number of particles. Whereas weight is a vector quantity because it is having magnitude with a direction. Right now, as I was telling this thing, weight is due to the gravitational pull, and the gravitational pull is in the downward direction. Hence, whenever it has been asked for the weight, weight acts in the downward direction. Weight जो है वो हमेशा नीचे की तरफ काम करती है. ठीक है. फिर जब हम लोग मास के लिए देखते हैं, so as it is a scalar quantity, thus it remains constant throughout the universe. तो जब मास के बारे में बात किया जाता है तो ये दुनिया भर में कांस्टेंट होती है. इट डजंट चेंजेस फ्रॉम प्लेस टू प्लेस. इट रिमेन्स सेम थ्रू आउट द वर्ल्ड. दुनिया भर में ये सेम रहेगी. नॉट ओनली इन द अर्थ, बट इफ यू विल टेक इट आउटसाइड ऑफ द अर्थ, देन ऑल्सो यू विल फाइंड दैट द मास रिमेन्स कांस्टेंट. बट व्हेन वी कम फॉर द वेट, so weight doesn't remains constant because it is directly related to the to the gravitational pull. So if the gravitational force changes, if there is a gradual change, decrease or increase in the gravitational force or gravitational pull, then we will observe that the weight of the body will also change over there. So this is a very important thing which you need to remember. So that mass remains constant, whereas the weight of the body can change. And because of this only, we can also say this, that mass of a body can't be zero. Okay, जो हम लोग बॉडी देखते हैं, किसी भी तरह की बॉडी देखते हैं, सो इट्स मास कांट बी जीरो। वो उसका उसका मास जीरो हो ही नहीं सकता है। क्यों नहीं हो सकता है? क्योंकि अगर मास जीरो हो जाएगा तो इसका मतलब ये होगा कि उसमें पार्टिकल्स नहीं है, और अगर पार्टिकल्स नहीं है तो मैटर की एग्जिस्टेंस ही नहीं हो सकती है। सो दिस इज द थिंग विच वी नीड टू रिमेंबर ओवर हियर। So mass can't be zero, but the weight can be zero. Such as, for example, if you will go to the open space, तुम धरती से बाहर चले जाओ, ओपन खुले स्पेस में चले जाओ, there you will find that there is no gravitation, and because of no gravitation, even though your body has the mass, but you will not have any weight over there. ठीक है? तो ये वेट जो है ये अलग अलग जगहों पर वेरी कर सकती है, और कहीं कहीं पे जीरो भी हो जाती है। जैसे कि इसका एक एग्जांपल और ले सकते हो। Suppose, for example, anything which has a mass of 60 kg on Earth. Okay, so 60 kg on Earth. So that mass will be 60 kg only on Moon also. So the mass is not going to change. But when we will go for the calculation of the weight over here, so on the Earth, its weight would be around to be 600 Newton. Whereas on Moon, its weight will be only around to 100 Newton. ठीक है? तो ये कैसे निकल के आती है? तो वेट का जो कैलकुलेशन हम लोग करेंगे, वेट इज इक्वल्स टू the force, and force is equals to mass into acceleration. Over here we will go for mass into acceleration due to gravity. So when you will solve for this one, the acceleration due to gravity would be 9.8 meter per second square. So instead of that one, you can round it up and go for 10 meter per second square. Okay, so this is the thing which you need to remember. So whenever you have to calculate the actual weight of any object, देखो हम लोग डे टू डे लाइफ में एक बहुत बड़ी मिस्टेक कर देते हैं। हम लोग नॉर्मल में किसी भी चीज के वेट को, या जैसे फॉर एग्जांपल हम लोग खुद के वेट को हम लोग केजी में कहते हैं। सो दिस इज अ कंप्लीटली रॉन्ग थिंग, बिकॉज केजी इज द यूनिट ऑफ मास, केजी इज नॉट द यूनिट ऑफ वेट। Weight's SI unit is Newton. So we need to represent it in Newton. So how can we calculate for this thing? So suppose any object is there, or any person is there whose mass is 60 kg. So you have to convert it into its weight. So that would be converted by into 10. Okay. So why it is so? Because we know this thing, that on each kg, the gravitational pull is of around to be 10 Newton. So if it is 60 kg, then the gravitational pull will be over there 60 into 10. So that would be 600 Newton. And this will create its weight. तो उसका weight कितना हो जाएगा? 600 Newton हो जाएगा। लेकिन अगर हम लोग इसी ऑब्जेक्ट का weight अगर हम लोग मेजर करते हैं on the surface of moon, then we will observe that it will be 1/6 what is on the earth. Because when we compare the gravitational pull on moon, then we find that it is 1/6 then compared to the moon. So this is the thing which you need to remember over there. Okay. So these are the very important terms which we had just now discussed, and with that one I'm ending up this class. I hope that you all had understood this thing, and if you are having any kind of problem or any kind of doubt, then we can discuss it in our next class. Okay, so thank you everyone. Goodbye, good night everyone.